Review video number 8, RC circuits. Refer to the figure to answer the following. When the switch is first thrown or closed at t equals 0, which resistor is effectively not a part of the circuit at that instant? And that is going to be the 10 ohm resistor, which is this one right here that I'm pointing at. That one will not be a part of the circuit effectively at that first instant, because at t equals 0, a capacitor acts like a wire. Therefore, it has essentially zero resistance, which means that any current would flow in that direction and basically nothing would go through this 10 ohm resistor. At that instant, let's figure out what all of these different values are. What's the resistance of the circuit at t equals 0? Well, at t equals 0, remember, this 10 ohm resistor is not a part of it. We just have basically this wire. It acts like a wire going around the lower right portion of the circuit here. So the total resistance of the circuit is 5 plus 3 plus 2. That's 10 ohms, which means the current going through the battery is going to be 20 volts divided by 10 ohms. That's 2 amps. And so that's going to be the current that's going through the 5 ohm resistor. That's going to be the current that's going through the 3 ohm resistor. That's going to be the current that's going through the 2 ohm resistor. But the current through the 10 ohm resistor, nothing at that first instant. The pressure difference across the capacitor, well, remember, the capacitor essentially acts like a wire. So there's no pressure difference at that first instant of connection. And the pressure difference across each of these resistors then will be equal to I times R. I times R for that is going to be 4 volts. I times R, 6 volts. I times R, 10 volts. I times R here, there's no current, 0 volts. And look at, there's your 20 volts of pressure drop. See, this is a 20 volt battery. There we go. Sorry, we've closed the switch there. There's your 20 volts. It drops by 10 here, then it drops another 6, and then it drops another 4, and we're back to the beginning. That was just at the first instant. How does the capacitor behave a long time after the switch has been thrown at t equals infinity? Well, at t equals infinity, the capacitor basically acts like an insulator or a break in the circuit, which means there's going to be no current moving in that direction, but there will be then current going through this 10 ohm resistor where there wasn't before. So now we've closed this and we're at t equals infinity. Now, what's the resistance that is felt by the battery? That is the total resistance of the circuit. Well, now this 10 ohm resistor is a part of things. So 5 plus 3 plus 10 plus 2, these resistors are all in series. So we just add them up, and that's 20 ohms, which means the current going through the 2 ohm resistor is going to be 1 amp. Through the 3 ohm resistor is 1 amp. Through the 5 ohm resistor, 1 amp. Through the 10 ohm resistor, 1 amp. Through the battery, it's not listed there, but the battery, 1 amp. The voltage across the 2 ohm resistor, remember, voltage is I times R. So if the I is 1 and R is 2, that means that the voltage is 2. This one's going to be 3 volts. This one's going to be 10 volts. This one's going to be 5 volts. And look at that. There's your 20 volts of pressure drop as you go all the way around the circuit. The battery's a 20 volt battery, and you have a total of 20 volts that get dropped as you go all the way around. Now, what's the voltage across the capacitor? All right, well, the voltage across the capacitor, remember, whenever we color code circuits, we can say the electrical pressure, the voltage of that region right there is some value. And the voltage of this region here that's all connected, that's going to be the same value, some different value than what I've colored blue, but the same value there. So this color coding shows us that the voltage drop across the 10 ohm resistor and the voltage drop across the capacitor are equal. Red to blue, red to blue. So whatever the 10 ohm resistor's voltage difference was, which is 10 volts, that's got to be what the pressure difference across the capacitor is. Right there, 10 volts. So what's the charge on the capacitor plates? I always go back to the definition of capacitance. Capacitance is Q divided by V, and therefore Q is C times V. C is 6 farads, which is a huge amount of capacitance. And V we figured out was 10, so I'm thinking 60 coulombs.